Hi everybody, today we'll be talking about quantitative research. So this is obviously Foundations of Human Systems Engineering. I'm Russ Brannigan and let's get started. So as we talked about in a previous lecture, research, just as a reminder, is a way to gather scientific observations or gather data and the subsequent interpretation of the meaning of those data. And this is conducted in laboratory and real-world environments. And I think I mentioned before, it's important to be familiar with a wide range of methods because different types of research questions kind of lend themselves better to certain types of research methods. And so there's not going to be just one method that makes complete sense. You don't just choose one and apply it over and over again. Instead, you match the research method you use to the question that you have. So I also mentioned there's a couple different kinds of research. You can think of them as categories or questions. So sometimes we're interested in understanding how to get product ideas or something of that sort, and that might be useful early on in the design process when you're looking for opportunities, for example, and you can do interviews and observation and so on during that period of time. Then, once you have a prototype, you can kind of see the idea here. Evaluative research happens when you've got a prototype and now want to evaluate that and improve it over time. And what I call experiential research happens once the product is already released into the market and people are using it. And you can learn an awful lot from people after they've been using it for a period of time. So let's talk a little bit about qualitative versus quantitative research. Chances are you'll become quite expert at doing both, I hope. Qualitative research helps generate hypotheses about user behavior, but it's not great for testing those hypotheses. That is, it gives us ideas, but you don't know for sure that those ideas are correct. And often for testing the correctness of an idea, it's more helpful to have something that's a little bit more robust, something that requires a little bit more proof. And for that, you use quantitative methods. Some things like questionnaires can be based on verbal report, whereas others, things like formal experiments, are usually based on things like human system performance. For example, whether the person was successful using the product or not, or how long it took them in order to complete a task with the product. So let's talk about a few of these methods that are really usually considered quantitative, and they're quantitative because you can apply numbers to them to make decisions. So an example of that are questionnaires. Questionnaires have a lot of benefits. They have some downsides too, and I think I want to discuss both of them. So questionnaires enable us to ask a large group of people about their attitudes and behaviors and get that information relatively quickly and inexpensively. Open-ended questions in a questionnaire provide an opportunity for kind of rich responses. On the other hand, they're often a bit difficult to analyze because it's not just a matter of, especially with an open-ended question, just tallying how many people said what. People will be open-ended in their responses and you have to categorize them yourself afterwards. It can also be influenced by people's desire to appear socially appropriate. That is, people often don't want to tell you exactly what's on their minds because they're embarrassed and they want to, they don't want to look bad. So sometimes questionnaires, as another verbal response measure, are subject to people's, what they're willing to tell you, basically. So typically what I'll do is use complementary research methods, so observation and so forth, in addition to questionnaires. And you'll find this a lot of times. When you're trying to do a piece of research, you'll often use multiple types of methods in order to reach some kind of converging evidence for the answer. Sometimes just one method can actually lead you astray. It can be confusing. Here's an example of a Likert scale that's used in a questionnaire, or actually the phrase is Likert. It was developed originally by a person I can't remember their first name, but by the name of Likert, and it's kind of the most widely used question type. So participants basically express their level of agreement or disagreement with the statement. As you can see over here, I'm interested in using this medical device as an alternative to the one I currently use. And you can see strongly agree all the way to, strongly disagree all the way to strongly agree. One thing you'll notice in this 5-point scale is they have a neutral. That is, they have a, because there's an odd number of responses, you can actually choose a neutral. Other times we might want to have just 4 or 6, in other words, an even number of these things, when we're trying to force people to come over on one side of the scale or another. So a forced choice scale is one that doesn't use neutral, whereas a one like this actually does use neutral. It's usually common for Likert scales to have an odd number like this. That's the most common situation, but it really depends on the question you're trying to answer. If you're really trying to get people to kind of tell you one way or the other, then often an even number scale is a good idea. Okay, here's another look at this. This is a slightly different type of scale called a semantic differential. And in this particular case, actually, you'll notice my semantic differential is, that's probably in my book too, bummer. My semantic differential is not great here. This should say negative over here to positive over here, unstructured over here to structured over here, boring to exciting, and so forth. So unfortunately, my graphic is not great, but that's what we mean by a semantic differential. The meanings, that is the semantics, are in 2 sides of a scale. And people are choosing what they think. It's also very fast, straightforward for people to use too. Here's one of my favorites, and we've done it in a couple different ways, but it's called a constant sum. And what this means is, imagine you had several different features or functions, and you're trying to decide what's the most important or feature or function for this product to have. Well, if you just ask people, hey, would you like this feature or function, they're going to say sure, because why not? Right? But on the other hand, that added feature or function might cost more. It might make the product more clunky or more complicated, all of those kinds of things. So often we want to know exactly how important a feature or function is to people. We could rank them, and that's not bad. That's a good start. This feature is most important, this feature is second most important, and so forth. But we could also do something that's a like ranking called a constant sum. And in this constant sum, it's sort of like giving somebody, imagine you gave somebody 100, $1 coins, right? Gold, not gold coins, but silver coins, $1 coins. And had a big list of features, and they could distribute those $1 coins in any way they would like. So maybe one particular feature gets 56 $1 coins. And then another one gets 20 $1 coins. What that gets us to 76, etc. So now we got 24 more $1 coins to distribute, and you distribute those accordingly. The nice part is now we know it's basically what we call a ratio scale. Now we know that if something was worth $2 for choosing it, it's worth twice as much as a feature or function worth $1. So basically what you do is you distribute these things until you're out of your dollars. Well, you can do the same thing on software here. How important are the following things? You have 100 points. Customization is worth 50. The ability to do a one-click purchase is worth 25, etc. And you can see it always sums to 100. So those are some nice, really useful actually, I end up using them all the time, sort of verbal response types of qualitative measures. As I mentioned, the problem with verbal response, of course, is people can lie to you. Sometimes they don't even do it on purpose. We're built in with biases that we have. One of those biases or one of those motivations is to preserve our self-image and our image to other people. So we tend to respond in ways that make us look a little better than we really are. That means you can fake some questionnaires and some verbal response measures. You cannot, on the other hand, easily fake biometric measures. So these use sensors to measure kind of hidden features related to things like emotion, attention, cognition, all kinds of physiological arousal. So these might include brain signals, facial expressions, eye movements, changes in your pupil, heart rate, galvanic skin, and we'll talk about all of those kinds of things. So let's talk about the first one, eye tracking. So eye tracking itself records where and how long people look at a particular stimulus. I'll give you an example. We recently usability tested instructions for use, that is IFUs. I don't know why they have to give them an acronym like that, but in the old days we would call them directions or instructions, but instructions for use for a particular product. And the participants often failed to complete the task, but it wasn't quite sure why they were having trouble. Was it that they couldn't find what they were looking for, or was it that they found what they were looking for but were having a hard time comprehending the way it was written? So one of the things we were able to do was to conduct eye tracking as people looked at these instructions for use. And sure enough, one of the things we found was that people looked at a particular sentence, and then they went back and looked again at that sentence, and then they went back again and read the sentence again. And there'll be 3 or 4 times. These are called regressions when you look at documents that way. You go back and read again. Well, that tells us it wasn't that they had trouble finding the piece of information they needed, because their eyes weren't bouncing all over the screen looking for this information. They found it. They knew which sentence it was. They just couldn't understand it because they were reading it over and over again. So that told us, when we looked at it, sure enough, this particular sentence was just worded really awkwardly. And in particular, it used passive tense instead of an active tense. It was a bit too long, used a little bit of unfamiliar language or nomenclature, and people had difficulty reading it. It just took too much effort. So that enabled us to figure that out really fast. Here's another example. We were interested in people who have to take intravenous medications pretty frequently, and they give themselves their intravenous medications. These are people with hemophilia who use medication that's ridiculously expensive and have to take this medicine 3 times a week. Well, we were interested in understanding. We could have just observed, and that was helpful. In fact, we did just observe for a while, but then we realized, wouldn't it be nice if we could put on eye tracking eyeglasses so that we could see things from their perspective? Because when you're looking at somebody, you're observing, and that's great, but you're not really looking through their eyes. This actually gave us an opportunity to kind of look through their eyes. And it gave us, some really good perspectives on how they arrange things, etc. One of the things that was interesting to me here, you can see in this particular view, this circle here, the diameter of this circle relates to how long they looked at that particular spot. The number in that circle is simply the fixation number. That is, they've already fixated on something 526 times before they got here. 525 times. This is the 526th. So that just tells you, okay, we've looked a whole bunch of places previously to this. But this tells you that they're looking at this thing for a long period of time. One of the things that was also interesting was they spent a lot of time looking up here on this, actually you can see here between the plunger and the actual fluid that they're injecting. And you can see it again, right? That's looking for a long period of time at that. One of the things we realized is because this medication is so expensive, you want to get every single last drop of it. On the other hand, you don't want to push, because there's usually just a little bit of an air bubble in there too, and you don't want to inject air into your veins. It won't hurt you too much. It's just not great. If it's a huge amount of air, of course it would, but in this particular case it's not enough to hurt you, but you still keep the air out of the vein if possible. It's just good practice. But that became really clear to us. This wasn't the interesting part so much, although it's challenging. One of the things that was challenging and that people paid the most attention to was figuring out how to inject every last drop and keep the air out. And that was really good information for our client who's working on ways to do that. Here's another one, facial expression analysis. We're pretty good, we're reasonable at faking emotions, but we're not perfect at it. And it takes a whole lot of effort, cognitive effort, in order to do that. So But we also notice we can usually tell when somebody's in a bad mood kind of by the way by looking at their face, right? We can tell if somebody's angry if they get red and their nostrils flare and their eyebrows kind of furrow. They might be angry, right? We can tell when somebody's confused. Often they have a confused face. We can tell if somebody's happy because their facial muscles will go up on the side, their lip muscles and so on. Their eyes might even crinkle a little bit with the zygomatic muscle, it's called. And so we can tell that, but wouldn't it be nice if we could have some software that enables us to classify these emotions? And people have worked on this for quite a long period of time and now have figured out algorithms for doing this. And this is called facial expression analysis. So you can see this fellow is using different facial expressions, and that's showing up over here on this. So this is nice if you're trying to understand kind of people's emotional reactions to your products and so on. I should mention that in practice, well, in fact, I probably have that on the next page. In practice, in my experience, it hasn't worked quite as well as I hoped it would work. It's great if you show somebody things like, things like videos or something like that, advertisements and things like that are supposed to make them laugh. You'll be able to detect their emotion from laughing and so on. But in just using a regular user interface, it doesn't work quite as well. Instead, it probably is used best, like a lot of other things, in combination with other pieces of software or other types of research methods. Here's another one that actually I have found some very good use with. That's called galvanic skin response, or GSR. So on our hands and various other places, feet, fingertips, foreheads, etc., we have these little sweat glands called eccrine sweat glands. And they're different than our regular sweat glands that we get sweat from when we're outside and exercising and all those kinds of things. They're smaller, and they produce just a trace amount of sweat, usually several times a second, in response to how our sympathetic nervous system is acting. So if we're aroused, if we're joyful, if we're fearful, all of those kinds of things, or high cognitive demand, what we call mental sweating, people will have a little bit more sweat on their palms, for example, or on their fingers. And with that sweat comes electrolytes, right? Chloride and sodium and things like that. And that makes, it increases our electrical conductivity. So the skin surface becomes a bit more conductive. GSR, galvanic skin response, measures this. This is a product I use quite often called Shimmer, and I've used it with Tobii systems and with some other types of systems. And it has really been useful in indicating when people are aroused. So for example, when they're working hard mentally. We did a project with a motorcycle manufacturer, for example, and people wore these as they were driving around and around town. And one of the things we recognized, when this thing tended to spike, it's because they were making a go or no-go decision about when to pull out into traffic or something like that. That actually requires a fair amount of cognitive effort. You're trying to integrate a lot of different pieces of information about choosing whether to go one place or another. And that was really interesting. Thus, if you could help people figure out how to make that decision or make information more readily available, you might be able to decrease that sort of mental sweating. I should mention that there's a small delay between when your sympathetic nervous system kind of kicks in or responds to a stimulus and when the glands are sufficiently activated. So it's usually about a second and a half after the detection of a stimulus that you can detect a change in the galvanic skin response. Here's another example of electroencephalography, or EEG. In this case, as you can see in this picture, you place multiple electrodes on the scalp, and those are used to measure fluctuations as nerves in the brain, or neurons, I should say, in the brain communicate with each other. And this helps us provide some information about when an individual encounters a stimulus and kind of what kind and how much sort of mental activity is going on when people are using this. In my experience, I've had some difficulty doing this in my research simply for very simple practical reasons, like it's hard to keep the electrodes on the head, especially if somebody has a full head of hair. So if you could find people just like me and only had a sample of bald people, well, it's not too bad. But usually we want a sample of more than just bald people. And in my experience, just from a practical perspective, it's been difficult. But I think if it's one of those things that's really important for you, it can be done. You also end up losing a fair amount of data from time to time, so it's an undertaking. On the other hand, it does provide you some information that you might not get otherwise.